We have been discussing about the process, about the ARIMA process. And we said that there are certain requirements that have to be met before we can model using ARIMA. Firstly, dapat after we plot the data, we have to convert it into a stationary data if it's not that stationary. So we need to make the data stationary in order for us to be able to make use of the Box-Jenkins approach. And then after we have made the time series stationary, we plot the ACF and the PACF in order to determine what type of ARIMA process we can use for our model. That was very important before, and up to now naman kailangan pa rin siya kasi dapat maganda kung may idea tayo anong AR process ba to. So we take a look at the PACF, no, for AR, and for MA we take a look at the ACF autocorrelation function, correlogram. So based on that, guys, makakapag estimate tayo, makakapag-try tayo ng model. Now, the only difference is that before, talagang ima-manual natin yan. Kunwari, nag-ano tayo na, baka AR2 process to. So, then we compare that with baka ARMA 2.1, ARMA 2.2, or ARMA 1, or ARMA 0.1, etc. No? So, pero ngayon, with the help of yung auto.arima function, or even the ARIMA function, guys, mas strict nga lang si auto.arima, we can already model. Now, I think last time we reached a parang a wall kasi it turns out that parang iba yata yung lumalabas na model using that auto.arima. So let me just check if my objects are still here. Let's have a quick review of this. Okay, is my Apple data still here? Let me check. Okay, dito pa siya, no? So my Apple data is still here. Okay. All right, so we were working with the Apple data, di ba? Tapos ang ginawa natin, kinuha natin yung adjusted close na. Let me check if it's but ayaw mag-print. Ayaw i-view. Sometimes guys, naglolo ko tong R ko eh. But ayaw niya mag-view. So long. Okay, so habang hindi pa siyang viewed, ituloy ko lang to, no? So in fact, what we did was to get the adjusted price. Hindi pa yung mag-run habang may naka-pending pa na escape that. Hang na naman siya, guys. Sorry, ha? Pause ko muna. Okay, so this is just a quick review kasi na we were able to do this last time. So we plotted, pinat natin siya, no? So itong pa-plot lang natin ngayon. We can see here that our data is definitely, oops, what happened? Nag-run na ba ako ng ano? Some packages. Sorry, ah. Library ko muna. nasa 426. Okay, if we take a look at the plot, we know, guys, that the plot is not stationary, no? Yung Apple data, yung prices, Apple prices. Taking tagal talaga, oh. Dito naman pwede i-run to. Ayan, okay? So there's a trend, guys. So definitely this is not stationary. So there seems to be, we're not sure if yung seasonality na to, hindi naman apparent yung seasonality, no? So we need to transform the data so that it becomes stationary. So what we did was we difference the data, di ba? Nag-difference tayo ng data. Okay. Just use the diff function. And then pag pinat natin yung diff, okay, you can see here that the data is already stationary except for some volatility clustering here. Now, indicative to, guys, na baka hindi kakayanin ng ARIMA to. So another model to do yung volatility clustering, hindi niya kakayanin yung model. Pero kung i-disregard na natin volatility, so this is already stationary, looks stationary visually, then kakayanin ng ARIMA yan except for the volatility, which will require an arch-garch process. Autoregressive conditional heteroscedasticity or generalized autoregressive conditional heteroscedasticity. Okay, so we also tried, guys, na kinuha natin yung log, di ba? We did this, we got the log of the data and then pinat natin. Okay, yung log, guys, did not address the trend. Okay, log can quiet the data in terms of yung pagiging yung seasonality niya, pero hindi yung trend. Okay, so kung wala namang stationarity, kung wala namang seasonality, then okay na yung okay na yung difference data. Dito ang ginawa natin, we also got the difference of the log. Ginagamit natin yan, guys, pag may trend na meron pang seasonality. This is the best way to go about it. Get first the log and then get the difference. Okay, so dito medyo nabawasan ng konti yung volatility clustering, but there's still here some pockets of volatility clustering, which sabi natin might not be, ARIMA will not be able to might not be capable of modeling. Okay, so we said, guys, that yung stationary na, hindi, it doesn't have to be just visual. We can use the ADF test from the package time series to check statistically for the stationarity. So okay, ano nangyari dito? Okay. And the AAPL. Kasi itong difference, okay, may NA siya, no? So, let me just DAAPL. Tanggalin ko, guys, yung DAAPL. Tanggalin natin yung first row. Okay. So I'm removing the first row and Asia, no? Hindi magra-run yung mga statistical test natin pag So we can now run this. Okay, guys, notice, guys, na medyo mabilis lang ako kasi na-discuss natin to. All right. So according to the augmented Dickey-Fuller test, ang null hypothesis kasi natin dito, the time series is not stationary. You have the Dickey-Fuller stat of -12.249, log order 12, and then p-value is 0.01. So we reject the null hypothesis that the time series is not stationary. So tama tayo just by visualization na yung difference na AAPL, difference na Apple, is already stationary. Okay? So from there, we can now, there are other tests. Ito another test, no? This is using the, from the URCA package, this is the, okay, iran lang natin to. Ito yung portmanteau test. And summary. Oops, hindi. Okay. Ito lang. Start lang siya. What happened here? Bakit ayaw mo? Nag-log si equal to 0 kasi ito. Okay, guys, sabi lang I'm not sure why nag-work mo to dati, di ba? Bakit yung nag-work si ano? Let me see. Baka wait, guys. Ano ko nga to? Okay. Bakit hindi siya nag-print? Binigay lang yung T-stat pero hindi niya binigay yung ano. Hindi niya binigay yung portmanteau test. Dito ba yun? Ayaw din. Okay, sige guys. Feedback nga guys. Does it run sa inyo guys? Ito, pagrinan natin yung yung unit root test ng sa URCA. This is the unit root test. Magbibigay sa atin ng portmanteau na na results. Kindly feedback please kung nag-run sa inyo guys. Kasi mag-generate ng box pairs, yung box test. Kung may unit root ba, aka guys, pag may unit root, di ba, ibig sabihin nun, hindi stationary. Okay, Ziska, nag-run. Pwede, Ziska, could you kindly share your screen? Pwede ba? Gawin kitang co-host. I'm sorry about this. Okay lang ba? Okay lang, Ziska?
Sige po.
Okay, sige. Thank you. Sorry nagkakaproblema talaga itong R ko. Okay, stop share ako. So let's request Ziska to share her screen. Okay, sige. Thank you. Let's see. Go down. Ayan, okay. So ito guys yung ito yung portmanteau test, ito yung unit root test, no? Okay, sige, go down pa. All right. Okay, tingnan natin to guys, no? So this is yung value of the test statistic is negative 48.98. No? Ito yung test statistic niya. Okay, ang dito, ang null hypothesis, nakalagay ba yung null? Go up nga. Okay, hindi nakalagay. Sige, go down. Okay, tapos hindi niya linagay kung ano. Okay, F stat. Ito. Pero ito, hindi nakalagay. No? All right, what does this mean? What does this mean, guys? So ang ano nito, ang test nito is that there is there is a unit root, no? If kindly guys isulat niyo yung ano ang null hypothesis natin dito is that there is a unit root. And we know guys, 'di ba, yung by definition a unit root is equivalent to, pag sinabing may unit root, then it means na hindi stationary yung ano natin, time series natin, no? So if you can see, the value of the test statistic is negative 48.9. Okay? Negative 48.9. Kung ilalagay natin sa number line yan, negative 48.9, and then we compare it with the critical value. No? Sa 5%, ano yung critical value, guys? Sa 5%, kasi we're using that as our significance level. Sa 5%, ang critical value natin is negative 1.95. Okay? I don't know if you recall that. Guys, sandali. Pwede ba ako mag-ano dito? Hindi ako pwede mag-ano, no? Hindi ako pwede mag-annotate if I'm not presenting. Okay. Okay. Anyway, guys, see, negative 48 is less than negative 1.95. Si negative 1.95, guys, imagine nyo may test, may ano kayo, may distribution, tapos si negative 1.95, okay? Si negative 1.95, siya yung critical value. Okay? Tapos ang test stat natin si negative 48, which is to the left, no? Of negative 1.95. If you recall from your basic stat, guys, okay, ang critical value natin negative 1.95. Any value that's to the left of negative 1.95, or since two-tailed, any value to the right of 1.95 naman, they belong to the rejection region. Okay, I hope you recall that sa stat nyo. Pag nasa rejection region, guys, it means that, anong result nun? Pag rejection region, we reject the null hypothesis. No? So ang null hypothesis dito, there is a unit root dun sa dun sa data natin, yung DAAPL, difference AAPL. Therefore, ang conclusion natin, guys, we reject the null hypothesis that there is a unit root, no? AKA that the data, that the time series is not stationary, no? Okay? Bilang guys, I'll just answer the door. Okay. Okay. Okay, thank you, Siska, for that. No? So let me share the screen again. Okay, hindi lumalabas sa akin. Hindi talagang may problema tong ano ko. Either yung computer ko or ano. Okay, so I'll not I'll not test again. Anyway, alam natin guys na ano na stationary na siya, no? And then once we know that it's stationary, di ba, we plot the correlogram. Tapos dito kasi makikita natin kung possibly ano siya, AR using the PACF or MA using the ACF. So we can see here that there are significant spikes, significant spike at 1, and then here we have at 6 yata to, no? So it's indicative that this is an AR process, no? So pwedeng AR, baka AR6 or AR5, no? Tapos dito din MA, mukhang may mga significant spikes din at certain lags. So might be guys, ano to, baka malamang ARMA to, no? ARMA, that is my question. Okay. All right. So, and then how do we now determine, guys, kung ano? How do we now determine yung model? Yung long way, guys, we use the ARIMA function. Pero ang pwede natin gawin yung ano, yung auto.arima, di ba? So here we're creating a model called mod1. Auto.arima siya. The difference ng AAPL, and tanggalin ko na muna to, no? And then trace. Okay. So dito lumalabas, guys, na kailangan pang mag-differencing ulit, no? 1. Lahat dito 1, no? And then the best model is the one with the lowest AICC, AKIK information criterion corrected ito, 7070. And it turns out that it's ARIMA5 So, di ba, ang ginawa natin, nag-try tayo na i-model yung ARIMA, yung ARIMA 500. Ibig sabihin, hindi na magdi-difference. No? And this is what we got last time. So, yung ano niya, AKIK corrected is lower than ano, lower than yung ARIMA 510. Okay? All right. Then medyo research ko ano kung how is the yung auto.arima function from the forecast package. Medyo may mga nakita lang ako na ano na may mga assumptions kasi diyan, guys. Okay, so let me just flash this. Okay. So I researched on the auto.arima work. Okay, so here guys, siguro kailangan muna natin we will just put our complete faith no on the auto.arima package. Kasi yung forecast package guys, it was developed by Hindman. Hindman is an authority sa forecasting sa time series, no? Forecasting ng time series, authority to. So may mga books to, mga technical books na kumbaga parang go-to guy siya kapag ano kapag time series analysis, no? Tapos ano siya yung nag-develop ng forecast package. And then may mga sinasabi siya dito na ano na assumptions ng auto.arima, no? So we're not going to the details of this, but there are reasons why ang answer natin naging ARIMA 510. Kailangan pa ng differencing. Tapos, yung ginawa natin, nag-ARIMA tayo na 500, according to the forecast package, hindi pwedeng i-compare yung AICC nun, no? Kasi ibang process yung ARIMA lang. Okay, let me show that to you once again. Okay. Di ba nag-ARIMA tayo ito, no? Yan, we use the ARIMA function. And then ang order natin, sabi natin 500. Now, according to the package, we cannot compare this na nag-500 tayo, okay? Na mas mababa yung yung AKIK nito, yung corrected, kaysa dun sa 510 na which was generated by auto.arima. So, the package was saying that magkaiba yung process ng paggawa ng auto.arima at saka yung process ng ARIMA na function. So they are not comparable. Okay? So that's what I learned, no? Dati kasi hindi ko alam yun na akala ko pwede natin i-compare yung result ng auto.arima kaysa dun sa ARIMA model ito. From the same package yun guys, no? Ito. So they are computed differently. Therefore, we cannot compare the AICC of the ARIMA coming from the ARIMA function vis-a-vis the ARIMA model coming from the auto.arima function. Ito kasi guys, may stepwise to, no? May stepwise na methodology na ginagamit diyan. Yung ARIMA yata hindi yata gumagamit ng stepwise. Okay, so we have to trust guys na I'm sure naman na alam nila Hindman yung ginagawa nila, that this really is the best model. Okay? Kasi nag-stepwise to. So ibig sabihin yan, inisa-isa nila, no? Tinatanggal nila isa-isa, which is what we learned from the stepwise regression. No? Okay. Alright guys, clear yun? Unless, tingnan natin guys, maglagay tayo dito na stepwise is equal to false. No? Kung gawin natin stepwise is equal to false, ibig sabihin, wag niya isa stepwise regression, yung auto.arima. Pag i-run natin to, okay. Alright. So ito, walang stepwise, ano? And it turns out that kahit walang stepwise, pareho pa rin, no? ARIMA 510. Ito nga lang, nag-introduce na ng drift. No? Okay. So, yung kanina, yung hindi natin linagay stepwise is equal to true. I think that's the default. No? Stepwise is equal to true, or hindi natin ilalagay. Okay. So medyo filtered na yung filtered na yung result. Okay. So 510, 70, 75. Okay, yung corrected niya 70, 77. All right? So we can now accept that with confidence na ang model nga is ARIMA. If you're looking at the Apple itself, Apple data, so ang model natin for Apple is ARIMA 520. No? ARIMA 520. Kapag yung difference AAPL, ang model natin ARIMA 510. Okay? Pause muna ako guys. Any questions about that? Clear ba so far guys? Yung again guys, binacktrack lang natin yung yung concern na nakuha natin last time na nag-auto.arima tayo tapos lumabas 510, ARIMA 510. Tapos nag-model na tayo using ARIMA, ginawa natin 500. Turns out that the 500 is better than the ARIMA 510. So bakit pa magdi-difference ng isa? Eh mas mataas naman yung AKA corrected kung hindi na mag-difference. So there, I was able to discover, hinanap ko yung mga notes ng dun sa forecast mismo na package, and yun, in-explain nila na hindi natin pwede i-compare yung result ng ARIMA function kaysa dun sa auto.arima. Okay, guys, clear please? Pasagot naman kung clear siya. Sana sana hindi naging mas malabo, no? Okay, thank you. Yung iba, guys, waiting for the others to give their feedback. Okay, thank you. All right. So dito, guys, plinat natin si residuals, no? And then kinuha natin yung autocorrelation. Actually, pwede naman natin gawin to, no? We can create this object. Let's call it receive, no? Receive 1 for residuals sa model 1. And then this is your model 1 and then residuals. Okay. So we're creating this object resid1 which includes yung mga residuals ng model 1. Okay, para dito sa pag-plot na lang natin si resid1. Pareho lang naman kakalabasan, but just another way. And then dito autocorrelation ng resid1 na lang. Okay. Run muna natin to. And then may plot tayo dito. Okay, ito no. So ito yung residuals ni model 1. Okay, constant naman yung no. Constant naman yung natin, yung residuals natin. Ibig sabihin, siya no? Stationary naman kasi dapat yung residual stationary. Okay, ang mga dapat titingnan natin guys sa residuals natin, dapat yung mga residuals natin hindi autocorrelated, no? Dapat independent yung mga residuals natin. Independent yung residuals natin from each other. Okay, we will have to test that. Tapos dapat yung average ng residuals natin 0. So it looks like 0 naman yung average, andi dito siya, centered around 0 yung average naman, centered around a mean of 0. Although may mga pataas dito, may mga pababa din naman dito, no? So nagba-balance lang siya. Okay? In fact, let's see, no? If we get the average of resid1, ay, sorry, average. Parang Excel lang, mean pala. Mean. Okay, so practically 0, no? Wala tayong problema sa condition na yun. Dapat yung average ng natin, ng residual should be 0, no? I-plot ko ulit to. Control enter. Oops. Okay, so mukha naman yung yung average ng residuals natin, mukha naman equal to 0. Yung kung autocorrelated ba yung mga residuals, kung if they're independent from each other, we have to test that. Tapos normally distributed ba? So we have to do a histogram for that, no? Kailangan mag-plot tayo ng histogram. Tingnan natin So sulat ko dito guys, no? Yung residuals natin dapat number 1, hindi dito na. Dito. Our residuals, model residuals natin. Okay, so we're diagnosing now. Number 1, dapat not autocorrelated. They should not be correlated to each other, or ibig sabihin dapat independent yung natin. Independent yung residuals natin. They're not dependent from each other. So kunyari, si error at time t should not be dependent on the error at time t minus 1. Tapos number 2 natin, mean ng residuals natin, yung average niya, it should be 0. Okay, and lastly dapat siya, normally distributed, no? So ito yung mga natin, ito yung mga pag-check natin ng ng residuals, no? Okay, for example, how do we test kung autocorrelated siya? Ito, paano natin matetest guys kung mamaya itong arch, no? How do we test this? We can use, pwede natin gamitin? Pwede tayong mag-statistical test, no? We can use, merong statistical test, dali, naalala ko ba yun? Box.test yata, no? Ano nga bang anong function yun? Wait, check ko lang guys, sorry. Hindi ko kasi kinakabisado minsan, box. Ayan, ito. Ayan. Box.test. Okay, yan. Box peers. So this is from the stats package. We don't need to install this kasi it comes preloaded. So alright, ito yung ano niya, ito yung so let's just try this. Copy natin, Control C, Control V. Alright, ang X natin is receive 1. Log is equal to 1, then type is equal to yung. No? Kasi dalawang klase yan, si peers, box peers, at saka si yung. Mas maganda si yung ano, ito, box peers or si yung box. I don't know if this is okay na siguro yung ano. Tapos fit DF. Okay, pwede natin isali ito. No? Fit DF, Control C, Control V. Okay, so si Resid 1 guys, this is model to ng DAAPL, di ba? Di ba? Tapos ang lumabas yung ano, ang lumabas yung ARIMA 510. Okay? Therefore, ilang degrees of freedom 'yon? Ilan ba i-aan doon? Ilan yung i-estimate na parameters? Yung 5, di ba? Kasi yung ARIMA 510 lang. Yung 1 naman, hindi naman parameter yun eh. Differencing yun. So, ito guys. ARIMA 510. Okay. If we're going to include this fit degree of freedom, itong model na to, ilang degree of freedom yung matatanggal dito? It's 5, no? Kasi yung 5 na to, AR process na 5 yan. AR1, AR2, AR3, AR4, AR5. Kung meron pa dito, kunyari 1 to, idadagdag pa natin yun. So magiging 6. Ito hindi, kasi differencing lang naman yan. Hindi naman ini-estimate yan. So here we put 5. Okay? Just to complete the, or pwede natin ilagay dito, type is equal to C. Pwede natin isama si box peers at saka si yung. So dalawa yung pinapasok natin, no? And then we close this. Okay. Log 1. Okay, log 1 ang konti naman. Gawin natin 10 logs, no? Hanggang 10 ano. Dapat walang space. Okay na? Receive 1. Log 10. Type is equal to 1, 2. So, yan. Isa lang. Alright, let's run this. Error. Bakit ako nagka-error dito? Ano naman tayo? Box.test. Okay, receive 1 yung residuals natin. Ano ba ito? Yung type ba? Sa example dito, walang tanggalin. Subukan kong tanggalin to. Type is equal to that. Okay, dapat i-define to eh. Okay guys, sandali. Ang syntax error natin. Hindi pa pwede, dapat may C to. Close, close, open. Kompleto ko nga ito. Baka di sa nagkaka-error. Yung box. Okay. box.test, receive 1. Log is equal to 10, type is equal to si box pairs at saka si yung box. Comma, close si type, comma, fit df. Close. Tama naman. Ayun, okay. Ito na naman siya. Isa lang binigay. Hindi binigay yung yung box. Paki-check nga to nito guys. Check nga kung nag-run sa inyo. Grabe tong ko, itong R ko. Hindi na maaasahan. Feedback guys nga, if you run this, did it also give the yung box? Si box pairs lang binigay. Please, anyone guys? Hello? Anyone guys? Pwede kung nag-run kayo, nag-ano ba siya, nag-print ng box pairs and yung box?
Sir, not yet po.
Not yet. Sige. Chat ko to guys para let's see. Chat. Ganun din, no? Box pairs lang din. Okay. So, kung yung box lang, tingnan natin. So, tatanggalin ko na itong C. So, let me just remove the box pairs. So, yung box lang linagay ko. Box mo. Okay. So, parang hindi yata pwedeng sabay. So, ito, guys, type C. Ito. Ito yung sample na syntax niya. Okay, so let's continue guys. Now you have to check, kindly check guys kung ano yung null hypothesis dito. No? Unfortunately, yung ibang these tests are sometimes applied to residuals from an ARIMA PQ fit, in which case the reference suggests a better approximation to the null hypothesis. Okay, ito guys yung fit, degree of freedom P plus Q, no? Provided of course that the lag is greater than fit df. Okay, fit df, mas malaki lag natin. Pero hindi yung sinabi yung null hypothesis. Okay, so you can easily find sorry hindi ko nakuha, no? So we have to be careful first kung ano yung paano natin i-interpret to. You can only interpret this if you know the null hypothesis. Ito yung sinasabi ko guys, no? Yung portmanteau test. Portmanteau means different tests, no? Parang ano yan, parang French word kasi yung portmanteau. Portmanteau actually means parang meron kang makikita nyo guys sa mga department stores o sa mga minsan mga mga dress shop, parang may o kaya sa hotel, no? Yung mga linalagyan ng mga coats, tapos may slider siya na may wheel na tinutulak, no? Yun ang portmanteau technically sa French, no? So ito guys, parang test siya ng autocorrelation na iba't ibang test ang linalagay. So andiyan si yung box, andiyan si box pairs, although ito hindi natin makita, hindi lumalabas dito eh. Sino sa inyo guys lumabas yung buo? If I use this, receive 1, palitan ko, lag dapat, lag the lag should be more than the fit degree of freedom. So 5 to kasi 5 yung AR, tapos wala naman yung MA process. So let me see if this will run. Wala. Wala. But I've done this before, guys. Nag-run siya, nag-ano siya ng ano, nagbibigay siya ng ibang ano. Portmanteau test talaga to, so maraming binibigay siya. Ayun, no? Ito pala, no? Ito, guys, no? Null hypothesis, sulat natin. So, ang HO natin dito, HO, is that the error terms are independent. No? Ibig sabihin, they are not autocorrelated. Yan, dito. Yan. The null hypothesis of independence. Okay. Or these estimates are known as portmanteau tests. Kasi nga, may box pairs, may Leung box. Kaya so hindi lumalabas ngayon sa atin. Okay. Any one of you guys was able to generate the portmanteau test? Several days ago na ano ko lang to na run yung portmanteau test. Anyone? Meron ba sa inyo? Paki-chat nga please guys kung at least yes or no para alam ko lang kung ano. Thank you Richmond, no? Meron ba? Meron nakaraan ng portmanteau test? So, sige. Kailangan kong i-test pala to, no? Kailangan ko i-check kung bakit hindi nagpo-portmanteau test. Okay. So, all right. Yung ano naman, yung normality test, okay? Pwede rin nating i-plot muna. So, number 3 to, no? Sa normality, pwede nating i-plot yung ano niya, yung graphically, pwede nating yung GG histogram. GG histogram ng residual. Okay. Let's see, oops, okay. Looks like, ano naman, looks like, parang normally distributed naman siya. But there's a test, no? Pwede tayo mag-test ng ano ng statistical test ng normality. So usually ang ginagawa dyan guys, parehong i-plot natin, tapos although medyo parang may pagka-pick siya, no? Pick siya dito sa mga tails. Okay? May mga konting outliers dito but generally guys, nagko-converge siya dito sa ano, dito sa ano natin. So this is dito sa center natin. Okay. Now, one very important thing that I'd like to discuss with you now is this one. Okay. Ano ba yung arch test muna? Iyan natin. Arch test. Plinat na ba natin yung residuals natin? O plinat na natin ano? And did we do the AC? AC. Oops. Saan na to? Bakit? Ano na tayo Library. TSM. Okay, then AC. Alright. Once again guys, tignan nyo. Dapat guys, yung model, dapat yung residuals niya, dapat white noise na. No? So if you take a look at this, yung band na to, may mga significant spikes pa siya. Okay? So it means guys na kahit na pinakuha na natin yung best model using the auto.arima, yun na yung pinakamaliit na ano na AIC corrected. Our residuals are not white noise. No? And what contributes to that? Well, what contributes to that, guys, is this one. Yun. Yung mga volatility clustering na yan. Okay? So ang tanong, is the ARIMA model sufficient? When in fact, makikita natin dito may volatility clustering, ano? Dito, yung residuals na to, this is already resid 1. So dapat sabi natin, dapat yung ACF nito at saka PACF dapat white noise na lang yan. Dapat wala nang significant lags. Pero meron no? Meron. And sabi natin, this is indicative that hindi nakaka-capture ng hindi na nakaka-capture ng ARIMA model natin yung mga volatility clustering na to. Yan. So, anong gagawin natin pag ganyan, guys? Ibig sabihin yan, hindi sufficient yung ARIMA model natin. Kung hindi natin ma-explain properly yung yung volatility clustering, then our model fails. So let's take a look at this arch test. Okay, so this is also from the TSM package. Okay, so this is performing the LM test. Okay, tapos hindi niya sinabi ito. RTN is a time series, and then M is the selected AR order. Okay, so tingnan natin dito, no? Let's go here. Let's make it simple na lang muna. From the TSM, we test the arch test, and then dapat dito, let's just use the resid 1 natin, no? Resid 1. Okay, and let's assume that it's an AR1 process. Run. Okay. What do you have here, guys? What does this arch test give us? So ano kayang sinasabi nito, no? Okay. Without going to the details, guys, ito, di ba sabi natin AR1 process, no? So ibig sabihin, si residual, i-model natin. I-model natin si residual, tapos using a lag 1 AR process. So anong nangyari, guys? Yung AR1 natin, significant. So what's the implication? Significant siya, significant at 0.001. Ibig sabihin yung residuals natin, yung residual natin, guys, pwede pang ma-model yan. It can still be further modeled. Diba? So yun. Balikan natin to, guys, itong if you recall, yung nag-simulate tayo, just to bring home the point, no? Okay, babalikan ko lang yung auto.arima natin, yung ito, yung nag-simulate tayo. Okay, I hope you still have it with you. The notes natin, haba na kasi nitong natin, no? AR process natin. Okay, where's that? Isa na yung unang simulation natin. Was it this one? Yung 1-0. Ito to. Yan. So let me go back to this, guys. So di ba nag-ano tayo? Hindi, not this one. Kasi ito, simulate. Ito, no? Sinimulate natin. Andito pa ba si M1? Is M1 here? Is it still here, M1? Wala na si M1. So let me run this quickly. Okay. So i-plot ko siya. Okay. Stationary na si si data natin M1 which was generated by simulating an MA2 Bakit MA? Yung AR lang muna. Okay, ito, no? So Okay, sorry about that. Okay, ARIMA10. Simulate tayo. Okay. And then, okay, looks like it's stationary, di ba? Tapos, AC na lang to, AC. Sim, and then max.log is equal to 530. Okay, so let me plot the autocorrelation function. Okay, so significant at log 1 sa PHCF. Sa MA, slow decay. So this is indicating that this is an AR1 process. And true enough, guys, kasi generated model lang to eh. So let's nag-model tayo using ARIMA, no? So ito sinasabi niya na ang model natin AR1, no? Ganun din guys, kung si auto.arima ang ginamit natin, ang lalabas dito AR1 process din. There. AR1 pero siya with no coefficient, no? With no intercept, with no mean. Ito lumabas dito kay kay ARMA may intercept. Okay, so ang gawin ko guys dito ko i-run, kunin ko yung receive X na lang gagamitin ko receive X ni anong model to? ARMA 10. Our model is called ARMA10 and then residuals. Okay, then i-plot natin guys si i-plot natin si AC natin si receive X max.log is equal to 18. Okay. Okay, tingnan nyo guys. Ayun. Ito kasi, di ba yung data natin, sinimulate natin. Di ba? Sinimulate natin na maging AR1 process. Nung minodel natin, lumabas nga na AR1 siya. Nung kinuha natin residuals, tapos plinot natin, okay, what happened? Okay, di ba white noise na siya, di ba? Right? Nag-white noise siya. In fact, okay, if we were going to test this, di ba yung mga ginawa natin na test dito? Ito. Receive X. Okay. Yung ginawa natin kanina dun sa model natin, gawin din natin dito. Okay. What's the difference now? Pag nag-arch test kasi, ang gagawin natin dyan, di ba, AR1, imo-model natin yung residuals, tapos titingnan natin kung may makukuha pa tayong model sa kanya. Here guys, it turns out that your X, yung AR1 natin, is not significant. Okay, wala na talaga mapipigang model dyan guys, kasi white noise na yan, no? Diba? So, I was just illustrating guys yung yung difference itong isang model na yung residual niya white noise as compared to isang model na hindi pa white noise yung i-plot natin si receive X natin. Okay. Alright, if you take a look at the plot guys, zoom na lang. Okay. If you take a look at the residual X guys, you cannot see any volatility clustering, no? Diba? Up, tapos down, up, down, up, down. Hindi ito yung up, 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 tapos down, 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 down. So magkakaroon ng parang clustering ng data, makikita natin na napakaitim ng ano ng isang portion na kasi tuloy-tuloy yung up o kaya tuloy-tuloy yung down. Unlike this one guys na hindi correlated yung mga ano natin. No? They were not correlated. Diba guys? Clear ba? And if we check for example yung GG natin, yung GG histogram natin, check natin. GG histogram ng resid X. Ito yung residual ng ano ng ARIMA10 natin kanina. No? Okay. So kita natin guys na ano na very normally distributed is yung ano yung residuals niya. So walang problema sa ano sa normality ng mga residuals, walang problema sa autocorrelation okay, based on the arch test. No? Unlike yung kaninang model natin, guys, this one, significant yung AR1 process. Ibig sabihin nun, guys, hindi natin na model yung ano yung residuals ng ano. It's not white noise, no? Okay, so ito yung mga last, guys. Now we can predict now. So after all is said and done, guys, isang gamit ng ano talaga ng ARIMA is prediction. So how can we predict? Okay, how can we predict? So ang model natin na ginamit is model 1 yung ARIMA510, no? ARIMA510, yes. ARIMA510 ng difference na ano? Difference na apple. So you use a predict function. This is also from the forecast package. Model 1 and then n dot ahead is equal to 22. Okay, so let's run this. It will give us a plot. And hindi pala plot, no? Sorry, I was waiting for a plot. No, this is not a plot. No? So, asa na tayo? All right. So, ano ba yung predict na ano na object? Okay, so it's a list of 2. No? Ito, pred. List of 2. Dapat siguro ang ginamit natin dito, pred 1. Let me choose pred 1 to match it with yung model 1 natin. Okay. Once again, so pred 1, it's a list of 2. If we take a look at this, view, yan, no? So we have this pred and the standard errors. Okay, pred. So these are the predicted values. So sabi kasi natin n dot ahead, ilang steps ahead, 22. Kasi that's for the number of trading days in 1 month. So parang 1 month na trading day siya na pinapredict natin. Okay, so you can predict guys, no? Pwede nating pa-predict yan. And then we can also forecast, no? We can use the forecast function. So isa predict, yung isa forecast. So using model 1, H22 ganun din, ano? 22 steps to and ahead. Tapos level of significance, pwedeng 99.5 or 95%. And then i-plot natin to. Okay, let's see guys, sandali. I am not sure if we can plot. Hindi yata natin mapaplot yung pred 1. Let's see. Hindi siya pwede. Itong forecast pwede, no? Okay, itong forecast. So, pwede natin i-plot siya. So, let's run this. Okay, so hindi lang masyadong apparent dito, no? Yan. You can see this guys. So ito yung ano niya, hindi masyadong kita, no? Let's create another ano siguro plot. Itong gray na to, this is your confidence interval. Okay? Itong blue na yan, yan yung ano, yan yung predicted, no? So if I, let's see, view spread 1 and then dollar and spread, no? Lagyan natin tong ano, let's create an object called spread1, okay, which is coming from the spread1 object and yung predicted nila. Okay, and then let's view this spread1. Oops, dali. Kasi babalik dun sa ano. Dapat head na lang. Head. Spread1. And then 10. Okay, so these are the predicted values, guys. Yung first 10. So after 1 day, ito, and then this one, and then this one, and then this one. So ito yung predicted values. Okay, so pwede tayo mag-predict sa ano sa using the forecast function. And then dito, guys, plot natin yung future value. Okay, tapos ito, let's plot na natin to, ano? Okay, hindi na kasi nag-mod 2 to eh, no? Okay, we cannot run this kasi hindi pa natin rinan si mod 2. Okay, then here, bakit mod 2 to? Sana mod 1. Ito na lang. Magawa na natin to, no? We have done this. So ano ba si mod 2? Okay, si mod 2, guys, we're using the original data, si Apple. If I run this, okay, makukuha natin ARIMA5 to yan, 520. 2 times the difference. Okay, kasi ginagamit natin yung original value. Yung isang model natin, ginamit natin yung first difference na, kaya isang difference na lang sa kanya. Okay, so we can now plot this also. So i-plot natin tong model 2. Okay, pero ang ginawa dito yung okay. Plot natin. Ito yung individual pa, no? Tapos ito yung AC function. Okay. So whether we use the original model, yung AAPL, o yung difference AAPL, pareho pa rin yung output nun kasi yung original AAPL versus the difference AAPL, pareho lang naman na ano sila kasi nag-difference pa ng isa. So it's already time, guys. So just this last few lines of code kasi tapos na tayo dito. At least tapos natin to, no? Okay, nag-model 3 dito. We have to go back there to check kung ano yung model 3. And then this one is okay, anong res? Okay, kunin natin yung res seed 1 na lang. Res seed 1. Res seed 1, let's plot that. Ay, hindi, pareho lang naman ito, no? And this is just using the okay, ggplot. So it's just the it's just the correlogram, no? Pareho lang siya. Okay, ito plotting the residuals. Okay, res is residuals best model. Okay, tingnan natin kung gagana to, no? Okay, hindi. Kailangan maano natin yung best model muna. Okay, so okay, I think guys, okay na to, no? Ito yung box.test natin kanina. Okay, fit.df is equal to 0. Ibig sabihin ARMA 00 yan. Okay, ito normality of residuals. Control C, Control V, yung residual. Okay. All right. So residuals are normally distributed. Okay, so si resid 1 guys, we reject the null hypothesis na ano siya normally distributed. Hindi siya normally distributed. While on the other hand, si isa kanina, yung resid X natin, yung galing sa ARIMA10, no? AR1. Okay, yan. Normally distributed yun. Okay? All right, guys, it's already time. I'm sorry I wasn't able to start with panel. So next meeting, guys, sa Monday, mag-record ako. You may wish to attend. Ang gagamitin natin yung panel na, no? Panel data regression. Kasi ito combination na ng time series at saka ng cross-sectional data. Okay? So let me stop recording for a while.